Hello. On behalf of BIC Magazine and our sponsor, Evoqua, I'd like to welcome everyone to today's webinar on Rent, Replace, Repair, How to Maximize Water Treatment Systems. This is Robin Dupree from BIC Magazine. First, a few pointers regarding your webinar console. You can maximize or reduce the size of any of the windows. At the bottom of your console are widgets to access resources, including a PDF of the slides and a webinar certificate. There is a Q&A box to text in questions anytime during the presentation. Feel free to submit your question and it will be addressed at the end of this presentation. If you experience any technical problems, please click the yellow question mark and we will address them accordingly. And now I'd like to thank our sponsor, Evoqua Water Technologies. Evoqua is a global leader in helping municipalities and industrial customers protect and improve the world's most fundamental natural resource, which is water. And now it's my pleasure to introduce you to today's presenters. The first is Eric Lundgren, Senior Manager of Evoqua Water Technologies. He has more than 15 years in helping industrial plants and facilities choose and design water treatment systems. As Senior Manager, he oversees a team dedicated to developing and implementing customized solutions for industrial facilities. And our next presenter is Mark Armenta, Senior Product Manager, Aftermarket of Evoqua Water Technologies. He has worked with Evoqua since 1998 when he joined its legacy company, U.S. Filter. With a background in industrial sales and global business development, Mark has experience helping customers make complex water treatment decisions. Currently, he supports Evoqua's aftermarket sales team, providing product expertise on parts for customers in industrial plants and facilities across North America. And now I will hand the mic over to Eric.
Thank you. Thank you, Robin. I'm very excited, thrilled to be here today, talking about today's topic, rent, replace, repair, and with the intent of maximizing understanding and the financial ramifications of three distinctly different approaches. All right, we're going to tackle the concept of ROI, return on investment, and I've got a little bit of a teaser here at the intro. In my opinion, I think return on investment within the industrial water space is a bit of a misnomer, and we'll kind of tackle that concept as we unpack our content today. All right, jumping to the agenda. Specifically, what we want to do, we want to put each of us in a position of understanding why specific financial methods are employed. So we'll talk about the different methodologies that can be used and why we've settled on the one we've settled on. A key takeaway as we move through today's content is the breadth of the cost factors to be considered. We're going to illustrate how timing impacts the financial models. And we're also going to talk a little bit about how your company's priorities greatly impact, cannot understate this, your company's priorities, it greatly impacts the conclusions on any kind of path forward when you're considering renting, replacing, repairing. And then I'm going to turn it over to my colleague, Mark Armenta. He's going to take us through searching for replacement parts, which is a part of the repair discussion, or this could be a retrofit type discussion surrounding existing equipment and systems. And of course, all of these elements are going to lead us to maximizing your water treatment system. The main concept for today's webinar, there we go. The main concept, again, rent, replace, repair, and we're actually going to tackle those in reverse order. We're going to talk about repair first, then replace, then rent. The overall kind of overarching terminology of CapEx and OpEx, capital expenditures and operating expenditures, and we're going to unpack those. Those get thrown around a lot, CapEx, OpEx, and my experience with respect, again, to industrial water systems, either processed water or wastewater, the CapEx and the OpEx are not really fully understood. And I don't mean that we don't understand what those definitions are. Certainly we understand the definition, but exactly what goes into that within the industrial water space, that's where we miss. All right, so most importantly, today we're going to try to have some fun with the content. We're talking about financials, accounting, that type of thing. And I would imagine on today's group, we've got many on the call like me that have a hard science background, maybe in chemistry, maybe in engineering, and a discussion on accounting, on financials for the next 20, 25 minutes might be viewed as a bit brutal. But stay with me, because really what we want to do, fundamentally what we all want to do within whatever company or organization that we work for, we want to put the company in a position to make the best decisions possible as it pertains to repairing equipment, replacing equipment, right? Or maybe there's another option, and we'll certainly be covering a third option today. So to open it up, we've got a bit of an interaction. Robin mentioned that it's a live version with the Q&A, so if you've got some questions, go ahead and post it in the Q&A, and that's going to bring us to the poll question. And I think Robin's going to pull up the pop-up.
Yes, it's there.
All right, so this is our first. We've just got a couple of these today, and the question is, what's the approximate age of your current water treatment system, right? And this could be either your wastewater system or a process water system. And when we're talking about process water, we're talking about maybe a makeup water stream that's being purified, conditioned for an automotive plant. Maybe it's for boiler feed water for a process application, or for steam, or for electrical generation, that type of thing. So process or wastewater, the current age of your system. Here we go. We got some results already. Thank you. And we see, I'm actually a little bit surprised. You can tell, but I expected a little bit more of a bell curve. But 15 to 30, over 30 years old, over a third, and then unknown coming in pretty strong. I would anticipate that is the engineering firms represented on today's call, and we'll certainly be unpacking the content with an eye towards those folks that are looking at financial evaluations from an engineering perspective and from a consultant perspective. All right. Our first slide today, and oh, hang on, get back to slide. Push this out. All right, so our first slide today, and this is just the financial model that we're going to be talking about. And I kind of want to set the stage. We're going to come back to the same model, show it from a rent, from a replace, and from a capital replace, and from a repair standpoint. But I want to make sure we all have the same common understanding of what it is that we're graphically going to be representing. So on the x-axis, pretty straightforward. You've got time measured in years. Right? The one note that I'll make here is that time begins from a financial modeling perspective in year 0. It begins today. On the y-axis, we've just got currency. So in this illustration, we're using US dollars. And the note that I have on this, and again, this is related to industrial water treatment. You'll note all of these numbers are negative. They're not positive. And the one caveat here that I want to make is if you're, and so I don't show any partiality, if you're Pepsi, if you're Coke, right, if you're bottling water and you're purifying raw water to go into your product, bottled water, that's going to look a little bit different from a financial representation standpoint. But for water that's viewed as a utility, so industrial process water, industrial wastewater, you're talking about a utility, it's all cost. They're all negative numbers. So we'll unpack that as we go through the model. And then finally, why are we using net present value, NPV? And the answer to that is because it's the most suitable for our purposes here. There's other financial models that you can use, other functions. You can use present value, PV. You can use IRR, an internal rate of return, which is actually interlinked with net present value. But the reason why we've selected net present value is because it allows you in each of the periods, year 1, year 2, year 3, to vary your costs. Your costs don't have to be the same. The cash flow does not have to be the same year over year. And with a present value, with a PV function, it does have to be the same. So we have a lot of flexibility, and it's more accurate flexibility in how we calculate the net present value for 3 distinctly different costs, 3 different models, so that we can compare them. The other couple of things we want to cover while we're here is the terminology. So when we talk about net present value, that function, that formula is accounting for a discount rate, and it's the net cash flow. I'd mentioned this earlier. It's the net cash flow of costs in each of the periods being evaluated. You can see on the graphic, year 1, year 2, year 3. Discount rate is every organization, every company, your finance department is going to have a discount rate identified. And that is the rate at which they're going to evaluate different financial decisions, and they assign a percentage to that. And we'll come back to that discount rate. It is different. There might be some questions on, well, is a discount rate the same as a WACC, a weighted average cost of capital, or an interest rate? And then we can come back to that in the Q&A. The answer is it's not. Those other terminologies are referring to very specific rates as it pertains to a business. A discount rate, once again, is going to be something that every company has identified within their finance group, and they will assign a discount rate that they use to evaluate their financial modeling. All right. Thank you. We've got through the hard part. Now comes the easy part, the fun part of breaking it down and going through each of the different models and each of the different 3 categories that we're going to cover. The first one is repair, right? So this would be an existing system, and we're going to make a repair to an existing system. As mentioned earlier, this could be a retrofit. It could be something like that. And again, it's the same graphic, right? The same period of time, the same net present value in US dollars. And for illustrative purposes, we've got some dollar amounts here, and just to make it a little bit more fun, think of this as you've got an existing car, right? And of course, with these dollar amounts, it can't be any car. So it's going to have to be like a Ferrari, a Lamborghini, maybe a limited edition Bugatti. You know, those go for about $4.5 million, depending upon the vehicle you pick. You're going to have a set cost. You're going to have a set number of repairs for the oil change, right? You're going to have some maintenance with that system. You ding it up, and you have to get it fixed. It's going to cost you. It's going to cost you some dollars, right? And so for this water treatment example, or if you happen to be a multi-billionaire and you've got a couple Lamborghinis or a Bugatti lying around, that repair might cost you in this illustration, $72,000 in year 0. And actually, in this model, in year 1, we have that exact same dollar amount again in year 1. We've taken those repairs over a period of 12 months, and we've financially modeled that out. And then we've taken the operating expenses for each of those subsequent years and modeled that out and plotted it for each year, 3, 4, 5, and 6. The key in trying to identify if you should repair an existing system or make a retrofit is not just in the repair cost, the $72,000 that we've identified here in year 0. It's in the ongoing operating maintenance expenses as you go out year over year. And this is what I was referring to at the opening with, we understand what OPEX means from a definition standpoint, but when we really break it down, do we know what all of these different operating expenditures are? There's a lot of financial factors to consider. So with a water treatment system, again, going back to, that's a real-life example that I showed you. It was an ion exchange system, or is an ion exchange system. And trying to understand the operating costs, there were a lot of factors to consider. The regeneration chemicals used, neutralization, you can see there. The obvious ones are the operating labor and the maintenance labor. Of course, not even listed here is maybe INC, right? Instruments and controls. And that could be a challenge to try to figure out what those costs are, because oftentimes the department that's operating the water treatment plant isn't the same department in which you get your INC labor. It's a different department. The costs are accounted for differently. So trying to understand what those real total costs are to operate your system in a plant can be difficult. You've got equipment costs, right? So what we're talking about here is not the big superstructure type equipment. We're talking about smaller pumps, right? Maybe some chemical feed pumps that have 3-year life or a 5-year life and have to be replaced, or diaphragm. You've got safety equipment for the water treatment system. We haven't even gotten into any of the PLC and controls on the INC side. There's environmental health and safety. On an ion exchange system, you've got tank permits for acid and caustic. You've got federal reporting, state reporting. That you could have additional things depending upon the local jurisdiction that you're in. And although those costs might not be huge, the amount of time and energy, I mean, somebody's got to do that, right? There's time and energy allocated and associated with executing those functions. There's wastewater. And so the point here, is do you always consider all of the factors on the operating expense, on the OpEx side, when you look at repairing an existing system? So let's go back to our illustration here. So we've changed this up just slightly. We're asking the question, should I repair an existing system? And so let me ask this question. For those of you that answered that your system was more than 15 years old, will that system make it just one more year? So let's just say we agree it's going to make it more than 1 year. Ask the other question. Is it going to make it another 50 years? Well, no, Eric, that's ridiculous. It's not going to make it another 50 years, heck. I'm not sure it's going to make it another 2 years. And the point is, so we've established it's going to last more than 1 year but less than 50. So now we have to use our experience. We have to use our existing operating knowledge of the system to try to quantify exactly how much longer it's going to last. Because from a financial perspective, that's important. In this graph, we've mapped it out in year 5 that we're going to have to replace the existing system. So in year 0, we're going to make the repairs. In year 1, we had another $72,000 allocated for some specific special repairs. We have ongoing operations and maintenance. And we know in year 5, we're going to have to replace the system. It changes the model dramatically. And that's why we have to identify how long we think things are going to last, and then we have to financially model and account it. You might do a couple of different models, assuming a couple of different variables from a life expectancy standpoint. A couple key takeaways here from the repair system. How do you know if you accounted for all of the cost factors, all of the operating expenditure factors? How do you even know? And my suggestion is partner with someone who does know, someone who does understand, and understands of how it fits into the financial modeling to be able to answer the question, should I repair my existing system? All right, so the segue now is to the capital side, to the replace. So let's take a look at what that model might look like. So just a couple of quick notes. Generally speaking, you'll see a replace net present value graphic look something similar to this. In year 0, you're going to have your capital expense, right? And so now we're talking about, again, thinking back to this terminology we use, CapEx and OpEx. We're on the CapEx side now, right? The capital expenditures. And so for a water equipment, for a water treatment system, we might have to include factors like installation, right? Do we need a building? Do we have any civil work that needs to be done? Soil examination, engineering, drawings. What kind of drawings do we want with our system? That's going to affect our price point, our cost point. What kind of tie-ins do we have to the existing system? Not just from a cost standpoint, functionally making those mechanical and those electrical connections, but also from a drawing standpoint. Right. So again, generally speaking, this is what the net present value graphic is going to look like in any kind of capital replacement option. If you think back to our fun little illustration with the vehicle, this would be the purchase price for our. I think I settled on a limited edition Bugatti, which I think runs just over 3.5. I think it's around $4 million, something like that. So this is my capital expenditure for my Bugatti. Now, some notes and some watch outs when you're executing a net present value calculation to replace an existing system from a capital standpoint. And I'll share this with a story that I've heard. I've heard some variation of this more than once. And it goes something like this. So you have a new capital system, and you've updated it with some technology, or you're looking to execute this. So you're getting some proposals back. And you ask the question, well, what does it take to operate this new system, right? What can I expect for operating expenses for the new system? And the answer comes back something like, well, it's new technology, and we've got this widget here and this widget here. Heck, Eric, the thing practically runs itself, right? And I know some of you out there are chuckling because y'all have heard this. The thing just practically runs itself. Well, look, water treatment systems, they have become more advanced, right? But I have yet to see a water treatment system that completely operates all by itself, right? And the other takeaway here, another one of the key takeaways off of this graphic right here is that we tend to focus on the CapEx, on the capital expenditures, and all of the things that we need to consider on the capital expenditures. And sometimes we forget that this graphic goes past year 0. We also have to understand all of the operating expenses for that replacement system going out year 1, year 2, and so on and so forth, right? Okay. We've covered repair for an existing system. We've talked about what that financial modeling looks like, some of the watch outs. We just covered the capital system. Now we're going to segue to the rent. And I've got to set this up a little bit because this is a little bit of a loaded terminology with rent. Rent can mean a lot of different things. So we want to, again, define our terminology and provide some definition behind the category, right? Rent can mean, hey, I have an existing clarifier system. It just went down. I need to get a temporary clarifier in here as fast as I can and run it for whatever that period is, 2 weeks, 4 weeks, 8 weeks, until I can get my existing clarifier back up and running or replaced, right? That's an emergency situation. We are not, I'll repeat, we are not talking about emergency situations. There's no need to financially model an emergency situation because it's an emergency situation. We're not looking to execute that on a long-term basis. We're doing it because we have no choice, right? What we're talking about here in this graphic representation, on this illustration, is as you can see here, renting equipment over a period of time with a specified quality of water and quantity of water at a fixed price for the term of the contract, right? So that's how we're defining rent here. We're buying water. You can think of it as a utility, right? And I've heard several different names. I'm sure they're not all listed here. I'm sure there's names out there that I haven't even heard of. BOO, build, own, operate, maintain. You can see them on the list there. Performance contracting, all kinds of variations off of that terminology as well. And typically speaking, this graphic that you see here with the blue line is pretty representative. You're going to have some upfront installation cost in year 0, right? So that's going to vary along that y-axis to some point, depending upon the size and scale of the system. And then you're going to have ongoing operating expenses, and of course you're carrying a capital expense in that graphic as well as it goes out. It's incorporated in. So the takeaway here on this is, again, within the definition of understanding this third option, and the other takeaway is understanding that the third option exists. Oftentimes we only think in terms of repairing an existing system or replacing an existing system. And the reason for that is because in many cases, those are the only 2 options available to us. But in water treatment, industrial water treatment, both on the processed water side and on the wastewater side, a third financial option does exist. All right, so what does it look like when we put all of these different graphics together, when we consider all 3 and we map them out together? And that brings us to the financial picture, right? And so on this graphic, you can see all 3 are charted out. On the top line, we've got the replace, the capital option with our $3.6 million upfront year 0 investment, right? That's my limited edition Bugatti. And there's several key points. We're going to spend a little bit of time here, right? We've got about 2 or 3 minutes on this slide. Your company's financial situation matters, right? If I'm a multi-billionaire and I got $3.6 million to spend on the Bugatti, great. You can drop that kind of dollars. Or it might be a different financial situation. You might have a situation where your fiscal year ends in September. October 1st is a new fiscal year. You have capital appropriated to your department and to your budget, but the project that capital was going to go to got moved out, got pushed out, got canceled, whatever the case might be, and there's a pool of money to spend, and you've got to spend it. That could influence which of these paths you take. So it's not simply going and looking at the chart and seeing, hey, what's the lowest one? And at the same time, this question comes up all the time as well. Hey, I've got this project with this fantastic return on investment. And it's not getting approved. I'm having a little issue here with my visual here. Let me get to where we're supposed to be here. Here we go. So I got this great ROI on this capital project, and it's not getting approved, right? So if you look at this graphic, repairing your existing system, right, in year 6 is up over $5 million. And if you took that out over 10 years, that's going to approach 10 million. That's going to be a little bit over $9 million. And your net present value on your replace, on your capital system, the red line, is going to push up north of $5 million, right? It's actually going to be a little bit closer to that 5.5 to 6 million because there's a few costs in years 6 through 10 that you can't see on this graphic. The delta on that is something over $3 million over 10 years. Why does that's a great return on investment. I can save the company $3 million, but my project doesn't get approved. And there's potentially several reasons as to why that's the case. But fundamentally, when you look at it from a financial perspective, the question is, what yields the best return for the company? And I'll remind you, all of these numbers are negative. So whatever capital goes into this industrial water plant, it is not generating any top-line revenue for the business. It is only costing money. So you can still save the company money, but you can't generate top-line revenue growth, again, because we're not bottling water. And that's an important consideration when you're talking about why projects get approved or why they might not. The last point here is the purple vertical line. That's the evaluation period. And every organization, every company is going to have some period of time that they evaluate capital expenditures, their return on their capital. Over what fixed period of time are we going to evaluate? And so for this model right here, it's set at 3.5 years. That's probably on the high side for any organization. I can tell you that's higher than what it is at Evoqua. So what happens if we move that? What happens if we move it to 2.5 years? What happens if we move it to 18 months? And you very well might work for an organization or a company that expects their evaluation to be over an 18-month period. Does that change our decision making? And that's important to understand. So I mentioned this return on investment thing, how I feel like that's a bit of a misnomer, right? And this relates to why the graph only goes to 6 years. I'd actually make the argument the graph should only go to as far as your company identifies the financial evaluation period at. If your company evaluates at 3.5 years, there's no reason to evaluate further out. You're evaluating at 3.5 years and less. No reason to go any further out. All right. We've covered a number of topics. My sincere hope is that each and every one has got at least one or two takeaways from this portion of our topic today. I've had a ton. You can tell I'm pretty passionate about this topic. I love talking about it. But now I'm going to hand off to my good friend Mark Armenta, and he's going to start us off with another poll question. Actually, I think Robin's going to take us through the poll question, and then Mark's going to take over and lead us through the closeout of the material today.
Thank you, Eric. Here's the next poll question, if you could help us out. On a scale of 1 to 5, how difficult is it for you to find the correct replacement parts for your water treatment system? Easy, we have parts and prices for all our parts. Somewhat easy. We sometimes have to look for the parts, prices, and drawings. Neither very difficult nor easy to find parts prices. Somewhat difficult. Sometimes we can't find the right parts, or very difficult. We always struggle to find the right parts and prices. Let's see what the poll results are here. Very in the middle is where the majority share is, where it's neither difficult or easy to find the parts or prices. Think about that, how you get those parts, prices, and components that you need for your system while we're going through the next few slides. When Eric's talking about repair, we think about a lot of the components that go into it. They're either repair components, they may be replacement at a component level. And so there's many of them that go into your systems. When do you consider that component repair? There's various times during the stages of getting equipment that you think about that. At the time of design, you may be thinking about it as far as parts that you're going to need future in the system. At the time of purchase, you may even purchase them at the time of the purchase of the system. You'll purchase the spare parts that were recommended. If you're planning for your preventive maintenance, you're going to need those parts at a turnaround. You're going to need those parts planning that length of that component in your system. Or if you have an emergency failure, you're thinking about that part as an emergency, immediate need. What information do you need to get that part? The most important thing you have to think about is that you need the correct part. You don't want to get the wrong part, and that creates additional delay. Or when you finally go to use it, it's not the correct part. You want to know the availability. When do I get it? Is it, what's the lead time on that item? And what that price is for that item. Where do you go to get that information? It could be very, very different places to get it. When you get the system, you'll have an engineering drawing of the system, and you may reference that drawing. You get an operation and maintenance manual with the system, and in the back you should have a spare parts list of recommended spares that you need. Maybe not all, but the recommended spares for spare parts and consumables. You may pick up and talk to the original manufacturer and pick up the phone and talk to an aftermarket person and ask them for assistance and telling them, this is the system I have and I need this component. And more today, we do it in our own lives. We use an online method. So an online catalog is getting more and more popular as a place to get your spare parts for your systems. The next question you ask is, when do you need it? And it's fast. It's varying amounts of fast, but you're really keying on, I'd like it as soon as possible. I don't want to have to worry about that part when I get it. So the question I have for you is, what if you combine all those different components into one platform? So you can see the engineering drawing, you get the O&M manual, you have the spare parts list, you have the ability to call somebody, and you have an online method of purchasing that part. So what I'm showing here is actually an online manual. So all those small squares, I know they're a little hard to read, but those are sections of the physical manual you may have received. This is the online version of that manual. And you can see one call out to the right where it says hydraulic pump assembly. We're going to click on that, and we're going to get a blown up view of that particular component. And in the bottom, you see a list of some of those part numbers and components that you have. In that particular item, when you click on it, here's a blown up section. You actually get to physically see that on the drawing, but it's interactive. So now you have the ability to choose that part and order that part online. If that's the part you want, you can actually execute that order. What are the benefits to that? It's easy to find your manual. You have it online, you have a link, you have an email. It's someplace that you can get at very easy. The information's always up to date. So for instance, I saw a lot of systems that go out there 30 years at the beginning of this, and that manual's been sitting on the shelf, and a lot of those components may be updated. They may have better features or provide a better performance. And what's nice is in the online manual, those up-to-date components will show, and you don't need to see the replacement. Actually, what you see on the screen, you're going to get the correct part every time because of that feature. You get to see the availability of the part. Is it in? What's the lead time? You get to see that information, understand the pricing very readily, and then when you place that order, you get to see the order status. Where is it? Is it executed? Is it shipped? What's nice about this is it streamlines the process. You're getting all the different features there. You streamline it, but you still have the ability to get the personalized support from your OEM and get that information if you need a direct contact if you have any additional questions. And then after that part ships, you get to see the delivery tracking and ongoing things for that particular order. What does this value provide? It optimizes your performance. You're always keeping your parts up to date. If it's a consumable, that performance may be related on the replacement cycle, or you're putting better parts into the system because they've been upgraded over time. You're doing it for preventive maintenance. You're planning that for that part in the future so you don't incur any downtime, or a part breaks and you're in emergency mode, but you're restoring your operations. This all helps you minimize costs when you're thinking about spare parts ahead of time, and it's easy to get that. It all relates to the uptime of your system, the value to that system of keeping that system up. I'll give you a quick example. I'm not going to read this specifically, but think about it. If you have a pump, a part, an RO pump, that value may be $1,000 to get that pump going. And the challenge is you lose that. And if you haven't thought about that part, or that part isn't easily available, you're going to have some conditions that exist where you may lose the quality of the water. In this case, like a boiler feed water, you may lose that quality. you may lose water altogether and you're not producing anything. And that could be tens, $100,000 worth of impact in your operation if that's affecting your production. And the solution is ensuring that you have those critical spare parts available. Maintaining those drawings and parts lists with an online manual is a very key way to do that. And you work with your suppliers to establish those parts lists, get the correct pricing, ensure the quick ordering, and use those online manuals for that help. In summary, so far we've covered understanding the specific financial models and methods that Eric had went through and how they're employed, and the insight into the expansive breadth of those cost factors and how they impact your decisions. Determining when to upgrade the systems gives you a little bit of a path on the timing of how you do that, and the company's priorities and the impact of those financial decisions. The value of spare parts and planning and ordering. It's critical to get the true operation costs for your current system, including both the CapEx and OpEx. And identify, if Eric had identified those three potential financial paths as opposed to only two that you may be looking at. And those spare parts play a key role in keeping optimum performance and uptime to your system. Remember to partner with your water treatment solutions provider and understand all those financial requirements.
Great.
Right now we're going to go.
Sorry.
Thank you, Robin. I'm going to pass this off to Robin. Thank you very much.
Thank you. Sorry about that. This now begins our Q&A section of the presentation. Please submit your questions, and our team will be sure to address each one individually. I'll give you about 30 seconds to submit your question, and I will begin with the first one. Does RRR include retrofit into equipment shells?
Yeah, I think I'll take that one, Mark. So retrofits, that's a good question. So retrofits would fall under kind of the existing system with a repair or with a retrofit. So you would use that type of net present value modeling. We have at Evoqua we use different templates, so we would use that type of template to map out that financial model.
You show an evaluation period as 3.5 years. Is this typical? And is this the same as a company's ROI expectation for a project?
Some people are paying attention. All right. So yeah, 3.5 years. It was, yeah. So we showed it at 3.5 years. I'd say, I'm probably drawing on a pool of maybe a couple of dozen data points from different companies that I've chatted with that have been forthcoming with that time period, and I would say 3.5 years is probably slightly on the high side. I'd say the average is probably somewhere between 2.5, 2 3/4, something like that. But pretty typical. Yep.
There seems to be a lot of factors that we need to think about when looking to replace some equipment. How do we gauge which factors are the most important?
I got this one, Mark. I think so. In determining which ones are most important, that's a good question. The short answer is that they're all important, and I don't think you know which ones are the most important until you've done the thorough evaluation. And as a part of that illustration, if again, you don't know what you don't know. And if you don't know what your permitting costs are, your environmental health and safety requirements, and I speak to that one out of personal experience, I didn't understand two factors, the cost factor or the resource factor, the time factor associated with EH&S of an ion exchange system. And for me, several years ago, the way I stumbled upon that is Evoqua has a number of very large regeneration facilities, which is very large ion exchange systems where we regenerate the resin. And in talking with those plant managers, we actually mapped out what our costs were. And I would not have known what a significant factor that was until we went through that effort. Again, that was several years ago. So in terms of knowing what the most important are, I would say the short answer is that they're all important until you can figure out which ones are the most important. You got to do the whole evaluation. You got to understand all of your operating costs and all your capital cost expenditures in order to be able to determine that. I know that's a little bit of a washout, but that's just what experience has taught me.
Since much of our equipment is old, we don't have the drawings or manuals to use to find information on replacement parts. How can we find the correct replacement part?
Eric, I could take this one. There's a number of ways you could find that information. If you know who your local rep is from that manufacturer, you can contact them. There's also a lot of key marking factors on the equipment, serial numbers and other marking factors that you can call into a aftermarket salesperson and get help on finding that. And the O&M manual is usually, we always carry that O&M manual, be able to look that up, and a electronic version may be available for some of your older equipment if you request it as well.
Okay, you mentioned that in financial calculations, there is no return on investment for water treatment equipment. Could you explain that further, please?
Yeah, I was trying to kind of poke the bear there a little bit. So technically speaking, a return on investment can be negative, and it can also you can also run a positive return on investment with a negative net present value. And for industrial water treatment systems, again, processed water or wastewater. On the processed water, it would be classified a utility. On the wastewater, largely the same. You're going to run a negative net present value. You're going to run a negative net present value. Your IRR, your internal rate of return, you can lower your negative cost, but it's not going to go positive. So your internal rate of return, it's interlinked. So net present value is the same as your internal rate of return when net present value equals 0. And I'll have to create a graphic and a chart that shows that on another y-axis so you can see how they're interlinked. But that's what I meant by that. The internal rate of return is going to be, it's either going to be negative or you're still going to have a negative net present value number with a relatively low IRR. And again, how that's evaluated by your financial team is not going to be positive when you're evaluating that against other options.
All right, next question. You seem to apply the life cycle cost over 10 to 30 years doesn't matter. Why would financial evaluation over the life cycle cost not matter?
Again, somebody else paying close attention. Yeah. All right. So I'm gonna speak to both sides here. It does matter in terms of how you account for it, right? So in the illustration where we showed an existing system with some repairs being made in year 0, year 1, and then on the later graphic we showed in year 5 having to replace the system. But our evaluation period's 3.5 years, right? So I'm guessing somebody was paying attention to that and said, hey, wait a minute, you just said that it really matters that you have that huge cost hanging out there in year 5, but your evaluation period is only over 3.5 years. And this is where modeling it is essential, because now you're going to have to work with your financial team or your financial partners within your organization to understand that larger picture. And then now how you account for that in the model. From a finance standpoint, you have a couple of different options on how you treat that. And that's exactly why you want to work with a partner that not only can help you with all the capital expenditures and all the existing operating expenditures, but also somebody who understands these financial models and understands those impacts, because it would absolutely affect the decision making there. But again, you're still only going to evaluate it over the period of time that your financial group has defined, right? Whether that's 2 years or 3 years.
Okay. The next question. Are the Evoqua service techs the only one working on Evoqua supplied equipment?
Yeah, I'll take that one, Eric.
Sure.
A lot of times in the plants, a lot of the maintenance areas within that organization will take care of a lot of the Evoqua supplied equipment. So if they'll lean on us if they need the expertise, or they contract with us to do that work. But many times the system itself, that plant will have a maintenance department that takes care of that equipment.
Okay. And 2 more questions. How does depreciation work with net present value?
Yeah, okay. So depreciation with net present value. You would, if you're looking at capital depreciation, and this actually goes, it's kind of interlinked to the previous question I took. You can absolutely account. It's net cash flow on an annual basis. So if you're looking at depreciation, you could run your calculations for depreciation. Many financial models will have that calculation taking 4 or 5 rows. But you're going to get to a net cash flow situation with your depreciation that you're accounting for, and you could absolutely include that and account for that for each year 1, 2, 3, 4 net present value. Yep, you can absolutely include it.
All right, and the final question. Does a financial modeling methodology hold up for both processed water and wastewater?
The short answer is it does. There are a couple of factors to consider, though. On the wastewater side, it's important to note that in the vacuum of any kind of ethical or environmental stewardship, no industrial plant would have any kind of wastewater treatment system. So your requirement for a wastewater treatment system in that case is from a regulation standpoint. So from a modeling standpoint, in terms of what you have to do or the expenditures that you may or may not have to make are regulated driven. On the processed water side, it's being driven by a utility requirement. So there is a little bit of a fundamental difference from that respect, but as far as the modeling goes, they hold up under either case.
Great. Well, thanks, everyone. Thanks, Evoqua, for a great presentation. We appreciate Evoqua for sponsoring this educational content, and we like to thank all of our attendees for joining us today. And we want to remind everyone that you can visit evoqua.com for more information, and you will see their email addresses on the slide right now if you'd like to reach out to them personally. The recorded version of this presentation will be available in about 2 hours at bicwebinars.com. Feel free to watch it again and share with your colleagues. On behalf of all of our friends at BIC Magazine, thank you.